geologists classify rocks by size sometimes. We got clay, silt, sand, gravel, pebbles, cobbles, boulders, okay, from small to large. What did the shy pebble wish for?
I don't know what.
To be a little boulder. Let's say this fictional geology professor, we'll call him Hal,
Hal.
dies at some point in the future.
Hal, the fictional geology professor.
Yes. I
He's a
can't
friend.
deal with my own death. That's far too scary.
Oh no, we're all immortal here, until proven otherwise.
Indeed. So anyways, Hal, the fictional geology professor, dies. Of course, goes to hell. The devil's there to greet him. Hey, Marty.
Are you all from here?
Oh, you're not Marty. Sorry. Fictional geology professor Hal dies and is greeted by the devil at the gates of hell. The devil gives Hal a tour of all the various ways that he will be tortured for eternity, and the tour culminates with the devil saying, "And here you will be boiled alive in a boiling lake of lava for the rest of your life." Now the fictional geology professor looks around him, notes that he's underground, and points out to the devil that this is technically magma because we're below ground.
Of course.
The devil gives an exasperated sigh and says, "This, you realize, is why you're here."
Hello again, astronauts. Today I'm sitting down with Professor Hal Wershow, an assistant professor of geology at the Central Oregon Community College. Thank you so much for answering my email and agreeing to whatever this madness is.
My pleasure.
Is a professor of geology who has done work with the USGS in Hawaii, at the Los Alamos National Lab. He's taught at multiple community colleges, and I'm going to ask him about rocks.
Yeah.
So, how do you use rocks to see the history of a region? Basically, how does geology work?
Rocks tell stories. That's the simplest way of putting it. Every rock tells you how it was formed. So these lava rocks around us tell us that there used to be liquid, molten, flowing lava moving over this landscape. What I find really fun about that is it allows you to use a lot of imagination. So if you've seen flowing lava, then you see this rock, then you start seeing, wow, how did this flow? So I guess we take this rock, we see how it forms, if we've been lucky enough to see that in the past, and then we can tell what used to happen here. So we happen to know this rock is about 75,000 years old. So I can tell you about 75,000 years ago, there were massive lava flows that completely flattened this entire region.
Wow!
Yeah, it would have been hot stuff.
So the type of the rock, the location of the rock, and all of your experience seeing rock cool in other areas where you do get to see it as molten?
That works really well for rocks that form on Earth's surface. So those are sedimentary rocks, kind of sediment, which becomes sedimentary rock, and then that's all sort of volcanic rocks. The problem is we had all these other types of rocks, like the intrusive ones, things like granite, form deep underground. All of our metamorphic rocks, and most of our sedimentary rocks actually do form deep underground. And the problem is we can't actually watch that happen.
So it's more like a best guess?
It's more like a detective game. You're following clues. So, for example, if we're going to talk about sandstone, that one's pretty obvious. You look at it and you can tell just looking at it with a little hand lens that it's made of sand. Then you look a little bit closer and you realize the sand grains are glued together. So you're thinking, okay, we had a big pile of sand, it got squished, there was some fluid that moved through it, the fluid dried out and turned into minerals, and that glued it all together. So like in that case, it's pretty easy. Some of our more complicated rocks, like gneiss, which is a metamorphic rock, it's a nice rock and nobody really can explain definitively how it forms, because that's happening way deep underground with incredible heat and pressure. And that's really hard. Like, even if we recreate that in a laboratory, we're not recreating millions of years. We're recreating a day at intense heat and pressure. So some of the rocks that form in very anti-humid environments, that gets closer to a best guess. Yeah.
I know that if you're supposed to bake a pie at 350 degrees for 30 minutes, just multiply the heat by 30 and it takes you 1 minute, right?
No. Geology is hard that way. We got this time thing that is really difficult for humans to grapple with. It makes us hard to understand things that happened in the past because we can't appreciate those time scales. And it makes it really hard as a human being on a day-to-day level to figure out what to worry about and what not to. This rock will fall. Guarantee it.
Probably not today.
Probably not today. Yeah. So I'm not going to worry about that one. I do worry about the Cascades subduction zone earthquake. That's going to happen. Can't tell you when, but...
How can geologists predict future events like the Cascades subduction zone earthquake or other volcanic eruptions, earthquakes? What clues can you see that something is coming or something might be coming?
Yeah, unfortunately, usually what we can do is see that something happened in the past and assume it'll happen again in the future. So earthquakes is a great example there. We know that the Cascades subduction zone earthquake has happened, I think, 18 times in the last 10,000 years. It seems extremely unlikely that the last one was the last one ever. It seems much more likely it's going to keep on happening. So that's a good example where we know it's going to happen, but we can't say when. Volcanoes, honestly, they're easier to anticipate because they give warning signs. There's all sorts of fun analogies of volcanoes being living beings, and it's kind of true. They burp, they fart, they explode in tantrums. And I guess the way that helps us as geologists predicting volcanic eruptions is before a volcano erupts, there's a whole lot of precursors. So for starters, the magma's got to start moving towards the surface. Magma moving through solid rock cracks solid rock. Cracking solid rock is an earthquake. So you get thousands of earthquakes before a volcano erupts. That's easy to see. We got little seismometers near the volcanoes, picks that up, tells us something's happening. There's other ways as well. But I guess what I'd say there is the volcanoes do a really nice job of warning you that they're going to erupt. They still don't tell you what day they will erupt, but they tell you that they're getting ready. So that's very helpful.
I feel like they could be a little more considerate. Like, if you know that a house guest is arriving, it does help to have, like, a time of arrival. Just, I'll be here sometime next few years or so.
Yeah, I don't think they give a shit about us.
I know that cinder is just frothy basalt, right?
Excellent.
And red cinder is just rusted frothy basalt.
Yes,
right?
Oh, you're doing very good. Yeah.
I watched your lecture.
Right. I like this.
But if cinder has the same chemical composition as basalt, which is high in iron, and that means basalt is high in iron, and basalt gets weathered too, why does the cinder get oxidized more or maybe faster than the basalt?
Yeah, so for oxidation to happen, you need oxygen, but it also is a lot easier if you have still molten stuff. So if it's still hot and gooey, it's much easier for that oxidation to happen. So like this stuff right here, when it cooled, there was no oxygen available because this was the inside of a lava flow. Sure, it's touching oxygen today, but it's pretty non-reactive. It's just cold rock. The cinders, on the other hand, as you said, they're frothy lava. When they're frothing, they're touching the air. Air's got oxygen. So that oxidation is basically happening as they're cooling, which is why we said did, not does. So that red cinder was red cinder pretty much when it cooled.
Okay, so when a rock rusts, it's while it's cooling.
You give this another 10 million years, it'll get red.
Okay, so it just rusts a lot slower when it's cold.
Yeah.
Nice. So I have many questions about obsidian, mainly because it's shiny. And I like it. It's shiny. So can you explain how obsidian is different from basalt from a structure standpoint?
The way obsidian cools, the molecules in it don't have time to organize into crystal lattice, meaning there's no organization, it's random. I used to play a game with little kids to teach them this, so I think it's actually a better description. So we simulated volcanic eruption. Kids run around circles like crazy. They're all the little molecules being volcanically erupted. And normal cooling behavior, I say like, okay, organize yourselves by hair color. And all the brown-haired kids and all the black-haired kids and all the blonde-haired kids organize themselves by hair color. Great. Now that's what a normal rock looks like. It's had time to cool. It's had time to organize. Obsidian, as they're running around like crazy in the middle of a volcanic eruption, I just yell, freeze! And you just have chaos. That's what obsidian is. All those molecules never get a chance to organize themselves. So that's why we call it glass. Glass, if you know the technical term, it's an amorphous solid. It just means it's pure chaos. There's no organization whatsoever.
But I noticed that on the internet, when people try to blow obsidian as glass, it doesn't work out. Any idea why?
I think it's the Earth laughing at us.
So which volcanic rock would you say tastes best? Cinder, basalt, obsidian, tuff?
Pumice.
Pumice.
Yeah, it's got a crunch to it, kind of like a good ruffled potato chip.
That makes sense.
Yeah. It's actually a common diagnostic test in the field. If you want to know whether a handful of dirt has volcanic ash, you just put it in your mouth, and if it crunches like broken glass, it's got volcanic ash, which is just pulverized pumice.
Ah.
So I've tasted it many times.
Do you have good dental insurance?
I don't tell my dentist that I do that. Pretty sure they would stop seeing me. I also make my students sign a liability waiver before they start chewing on the pumice.
Ah, okay. I like the idea of you going to the dentist and they'll be like, "Are you flossing?" Maybe. Did you stop eating rocks?
No.
But I floss after I eat the rocks. Can a lahar create a caldera, or does that have to be an eruption?
So caldera is technically a very large hole in the ground created by a volcanic eruption.
Okay.
So a lahar might come out of a caldera, but it doesn't.
Okay. So what would you say the likelihood of some sort of volcanic disaster in the next, say, 20 years would be? Because we've already had one apocalypse this decade, and I just really can't handle another. I need a few years.
So we need to be more specific about where. Are we talking about planet Earth, in which case 100%? Or are we talking about Central Oregon? Or do you
Well,
wanna-
I'm here, and I'm selfish.
Yeah.
So how about just the Cascades?
Cascades? Okay. Relatively unlikely. The most likely thing to erupt in the next 20 years in the Cascades is Mount St. Helens. If Mount St. Helens erupts again, it's probably going to be like it was in the mid-2000s, which was not a big deal. There were some lava tubes. Basically, imagine you squeeze lava domes. Imagine you squeeze a tube of toothpaste, the toothpaste goes up, it doesn't flow out. That's what sort of lava it was. Super sticky lava, it went up, it was cool to watch. It wasn't a big deal, it didn't hurt anyone. That's the most likely thing to happen in the next 20 years. I don't think we've got a lot to worry about in the next 20 years from our Cascade volcanoes. Don't prove me wrong, please.
No, let's not.
That's because you said the next 20 years? You'd said the next 100 years, next 200 years, we would change our answer.
Well, we'll all be dead of climate change before that, so.
Or natural causes.
Is climate change a natural cause?
Anthropogenic climate change is not natural. When we're burning fossil fuels to cause it, no, that's not natural.
Yeah, but I feel like the hurricane that takes us all out is kind of like nature's revenge. So it is a natural cause.
It's a natural reaction.
Ooh, I like that. So we'll all be dead of either natural causes or natural reactions.
That sounds good.
What are the different types of ways a volcano can erupt?
It either blows itself to bits, explosively, that's dangerous, or it oozes lava. That causes pretty colors.
Okay.
So the good news, and we're going to focus on Central Oregon. Central Oregon's fairly unique in terms of the Cascade range, in that we've got thousands of, well, less than 2,000, but more than 1,000, of oozy volcanoes.
And
What's
oozy is the good kind, the kind that brings those sweet, sweet tourist dollars.
Yes, sweet, sweet tourist dollars from lava flows from cinder. Cinder, when it's happening, looks like we call it fire fountaining. It's a fireworks show, period. It's shooting up into the air. It's amazing. It's super cool. You watch it at night. It's like the coolest thing you've ever seen. And it's very contained. It stays there. It doesn't blast itself to smithereens and kill everybody. It doesn't take out cities 30 miles away. It stays there.
Not taking out cities 30 miles away is a plus.
Yeah.
Then just 30 miles from a lot of these.
Right. So if another one pops up, odds are, worst case scenario, it shuts down a highway and we all get to watch something pretty heavy. So that's why I'm actually excited at the prospect of it, one of these oozy, effusive is our technical term, one of these oozy volcanic eruptions somewhere in Central Oregon, because they're probably going to be pretty safe. They're very easy to contain, and they look.
Hawaii and Iceland have had it too good for too long. Central Oregon is coming for them.
Yep. And to be fair, we used to have it really good.
Yeah.
We're in a quiet period. You go back 2,000 years ago, the people who were living here then were loving it. There was fireworks everywhere.
We are a long, historic program, and Hawaii and Iceland might be hot now, but we're coming back.
Yeah, we're playing the long game.
Yep.
Definitely. We'll be there. I'm confident.
So, would you say, like, if you were betting on who would get the best fire fountains in, say, the next 100 years, the next lava season, if you will, would you place your bets on Oregon, Iceland, Hawaii? Maybe is there another program we're sleeping on, another range?
If my goal is to make money, I would bet on Hawaii. But if I'm a hometown person,
Gotta
I'm
root for
betting
your
on Central
hometown.
Oregon. Like, I'm not. I only get one lifetime. I'm gonna be dead by the end of those 100 years. I want to see something here. I've seen volcanoes erupt in Hawaii. It's the best thing I've ever seen in my life. I want to see that happen. Let's see.
Freaking inconsiderate volcanoes. Even the pretty ones. See, they're like, I'm pretty, I don't need to be considerate.
Madame Pele is not known for consideration. She's known for giving life and giving death. And consideration does not go with it.
That's pretty fair. So we've talked about lava that erupts and lava that oozes. What is a lahar?
Yeah, so lahars are weird ones because they aren't necessarily part of the eruption. They often are, but don't have to. Basically, you need three things to make a lahar. Here's your ingredients. Number one, you need a lot of ash. Ash is not what happens when you burn a tree. Different type of ash. This ash is pulverized lava flow. It's shards of volcanic glass. So you need a lot of ash, and that comes from our explosive eruptions. That does not come from the oozy ones.
Okay.
Mount St. Helens, 1980, yes. Lots of ash. That's why it looked all gray and all that stuff. So you need ash. Now you need water. Water can come from usually three different sources. Number one, you can melt a glacier. That's what Mount St. Helens did. Great source of water. And that does happen during an eruption. Number two, you could have a big lake full of water, and that could be on your volcano. So, like, I think that would work for Crater Lake. If Crater Lake erupted today, that could be your water source. Or number three, and this is what happens in places like Indonesia, they have a rainy season with heavy-duty monsoons. Volcano erupts during the dry season, coats the sides in ash, then it rains 3 months later, and this isn't like sprinkle rain, this is like heavy-duty downpour. That's enough water to create a lahar. The third ingredient, you need a steep slope. Our tall, pointy volcanoes are very good at providing that.
Yeah.
So if you have a steep slope and a lot of water and a lot of ash, now you have mud going downhill at high velocity. That mud is strong enough to pick up rocks like this, as well as houses and logging trucks and trees and anything else in their path. Grab them and just rip them along and take them for a ride. So that, in a nutshell, is a lahar.
So a lahar can it happen years after an eruption?
Yep.
So as long as the ash is just there, chilling, and you get a bunch of water at a steep slope, it could just happen at any time?
They're most common during an eruption, but they absolutely can happen afterwards.
What do you think the odds of us getting a lahar in Central Oregon or in any of the Cascades, I guess?
So that ash needs to still be pretty fresh.
Okay.
So Central Oregon, the last ash eruption we had was about 2,000 years ago in South Sister. And there's plenty of pumice right around there, but most of the ash has been blown off or incorporated into the soil. So we don't have an imminent lahar risk in Central Oregon without an eruption. Certainly if there's an eruption that spews out a bunch of ash, we melt a glacier, boom, we've got a lahar.
Okay.
As far as Mount St. Helens goes, I would bet even there, the last really explosive one was 42 years ago now. I don't think there's an immediate lahar risk without an eruption.
What about Hood?
Hood last erupted in the 1780s, so again, there's just not a lot of ash available.
Okay.
There's other ways we can get nasty things. They're called debris flows. That's a whole other topic.
What is a debris flow?
Okay, we'll go into this
I want to
quickly.
know.
So this is where climate change is creating things just like lahars that can kill us today. So we've got our tall pointy volcanoes.
Okay. Tall pointy volcanoes.
You're fine here, just don't go to Sisters. Tall pointy volcano. Glaciers start retreating, Glacier leaves behind a pile of rocks called moraine. The
Okay.
moraine's a dam, and behind that dam is a lake because we just melted a glacier.
I like to go backpacking at Moraine Lake.
Yeah, Moraine Lake's actually not a big problem. No Name Lake is the problem.
I've been to No Name Lake twice in the past 3 weeks. We filmed a
Perfect.
bunch of this video at No Name
Good.
Lake.
So, fun fact, October 7th, 1966, No Name Lake had a debris flow come out. But basically what happens is you've got a dam made of loose debris. That's not very stable. You've got a lake behind the dam. All you need to do is drop a large rock into the lake or maybe a large amount of snow or ice. These things happen pretty frequently. And now you create a little bathtub tsunami that spills over the top, cuts down, and next thing you know, you have this charging mass of rocks from the moraine that are being fueled by water that's going steeply downhill.
You hike up that little waterfall to get to
Yeah. That's where the debris flow came from. Yeah. Isn't that
So
cool?
we're hiking up a debris flow?
Oh, totally.
That's
Yeah.
so cool.
It is.
Oh, so that's what all those rocks at the bottom
Yeah.
are. Oh, cool.
Yeah.
Oh, nice.
Yeah, so one of those could happen
Those
at
are
any
pretty.
moment. They're totally cool and totally deadly, just like a lava. So Sisters is in the direct runout zone of a number of those glacially dammed lakes. That's not the right way of putting it. Moraine dammed lakes in front of melting glaciers in the Three Sisters. And so I think the most dangerous one's called Carver Glacier, with Carver Lake in front of it. That's on South Sister. And if that one breaches its moraine, then the debris flow goes flying down the White Juice and goes into Sisters and spills out and kills a bunch of people there. So that could happen at any moment.
But Sisters has really good coffee shakes and food trucks.
Don't forget Sisters Bakery.
Sweet Easy is where it's at. They have 5 flavors of coffee ice cream.
Yeah, so maybe we should take some coffee ice cream, go up to Carver Glacier, and dump the ice cream on the glacier to protect it from melting.
Keep it awake, yeah.
And keep
Just-
it awake.
Keep it alert.
Alert.
Just
Yes.
vigilant.
Yes.
You gotta keep the glacier vigilant.
That makes sense. The more we anthropomorphize our glaciers, the better.
Well, they might take on human traits and become decent and tell us what's happening and when.
I think they are telling us exactly what's happening there. It's getting really hot. They're very good at telling us that.
Well, no, that's something we don't like to hear. I wanted them to tell us what we want to hear. Because if they tell us about climate change, we're just going to keep ignoring them. So we already talked about how I can't really handle, like personally, I can't handle another apocalypse. I really enjoyed this past pandemic apocalypse. That was super fun, lots of character growth, big season finale, but like, I just don't want to do it again because I might break.
Yeah.
So for purely selfish reasons, we've learned that getting rid of our preparedness teams doesn't work.
That was such a good strategy.
Yeah,
Huh.
apparently if you think there's a pandemic coming, so you make a pandemic preparedness team and then you cut it, the pandemic is not prepared for. So how do we do the same thing with volcanoes or earthquakes? Because we know a bunch of big earthquakes and volcanic eruptions are coming, we just don't know when. Much like we could prepare for the next pandemic,
Yeah.
how do we prepare for the next geologic event to either have early warnings, mitigation, and not just volcanoes, but also earthquakes, tsunamis,
Yeah.
all kinds of things.
So we've got some good news there in that we have the United States Geological Survey, and that is a large part of what they're all about, is trying to anticipate and warn about these upcoming disasters. And most states, at least in the West, have state geology departments as well. In Oregon, we have the Department of Geology and Mineral Industries, which we call DOGAMI. And in DOGAMI's case in particular, there's a really simple thing we can do there, which is have the Oregon State Legislature actually give them consistent funding. They keep trying to cut DOGAMI because DOGAMI keeps running out of money because DOGAMI's mostly been grant funded because the state won't pay for it. So that would be a really obvious example of the legislature needs to get their act together and give DOGAMI a consistent operating budget every year.
I don't understand. They created for it. Why should they have to pay for it?
Yeah, exactly.
It's their
Funded
child.
man.
They just leave it, let it go into the world, and
And it'll fend for itself.
yeah.
Except the years that it doesn't fend for itself and begs the state for money, and the state says, "Why do you need money?"
And Dogami's like, I'm literally your child.
Yeah,
Is Dogami over 18? I don't know how old Dogami
I
is.
think it is. But
Well, in that
Yeah.
case, this metaphor breaks down real fast. Creating preparedness organizations is enough. You also have to fund those continuously.
Yeah, every year with taxpayer money.
But then, how will we pay for all the military and prisons, and also military and just more military, just a lot of military?
Use our military to intimidate the earthquakes and volcanoes.
Ooh,
If you point a gun at an earthquake, it'll probably go in the opposite direction.
toward Canada.
Yeah. Or send it across the ocean. We do already have a lot in place to warn us about tsunamis. We can go to the Oregon coast and there's tsunami warning signs everywhere, and there's a robust system where if we learn that when it's happening, sirens go off and you run to the high ground. The big problem there is we don't have enough warning for our local tsunami, Cascades eruptions on tsunami. And the best thing to do there would be to plant a bunch of sensors literally on the subduction zone itself, which is like 100 miles offshore. And then we get near instantaneous warning, which would give everyone like 20 minutes.
20 minutes is a good amount of time to get in a car and drive to high ground.
Yeah, I wouldn't say get in the car because the earthquake's coming, and the earthquake will cripple all the roads. So I would say get on your feet and get to high ground.
Get on your feet and get to high ground.
And if you don't have functional feet to work, then hopefully you're in a place where you have figured out what your route is in a wheelchair or perhaps in a car if that's your only option, or whatever sort of mobility you have. So yeah, getting a little bit of extra time would be great.
Yeah. It's good to have preparedness plans for potential disasters like tsunamis. I have a couple other scenarios. This one's more of a positive scenario, but say we get one of these beautiful fire fountains and the lava is oozing, but it's oozing directly toward executive producer Marcia Remai's house. How much time would the Bad Astra team have to fly ourselves to executive producer Marcia Remai's house and dig a moat around her house so that she may have a lava moat?
That'd be really cool to film it as it filled up and the river of lava flowed around your house.
That's
That'd
the goal.
Be very cool.
That's what you get as executive producer of Bad Astra. You get a team of people digging a moat.
And I assume you'll have heat shields around it so nothing flammable catches fire and you won't be wearing gas masks to deal with the sulfur dioxide.
See, this is helpful information to have.
Yeah, if the lava was like flowing right over there,
Yeah, that's about as far from
yeah, anything that's wooden's gonna catch fire.
cut down trees.
Yep.
Oh, but those are so
Yeah, isn't that
wider.
difficult that the Earth doesn't give a damn about what environmentalists love?
Okay, so how much time would we have
Much
to
time, yeah.
get the gas masks, install the heat shields, dig the moats, relocate a bunch of trees?
Are you talking about time from when the lava exits the volcano to gets to executive producer what's-her-butts' house?
I'm talking about the amount of time from when we know the direction it's going. So when we know there's lava flowing toward executive producer Marcia Remai's house, to when we can dig the moat. Or
Gotcha.
how long we have.
So obviously that depends on how far away it is.
Okay.
But let's say for funsies it's 5 miles away.
Okay.
Then it depends how fast it's going. Isn't this annoyingly scientific? It's such an
Well, how fast would it go?
Yeah, so a river of lava that's going at a decent slope, I'm going to guess, could be 20 to 30 miles per hour maximum.
Okay.
But as you get to the edge of the flow, it slows down a lot. It's basically no longer channelized, and it's got to spread out. And at the point that it's spreading out, you can outwalk it.
Okay. So if we dig fast, 20, 30 miles per hour.
I think it's got a
Yeah.
chance.
Yeah, I think we just need a big enough team of people, and I'll get the gas mask to have on hand.
Yes. Gas masks are important. OSHA requires them.
That does make sense. We don't want to mess with OSHA. We've already pissed off space OSHA. So say we have permits to go backpacking by sisters for a few days. But there is lava eruption, lahar, climate change, mudslide, some disaster while we're out backpacking.
Yeah.
After we run toward it to get cool pics,
Yeah.
what do we do?
Go to the high ground.
Go to the high ground.
That works in most disasters, not all of them, but anything that has gravity involved,
Okay.
which would be lahars, which flow like rivers, which would be debris flows, which flow like rivers, or if you're on the coast, a tsunami, which is water, which is influenced by gravity. Anything with gravity, get to the high ground, and then it goes below you, and you get to watch it happen. It's like, oh. And we just won't talk about the things that don't really care about gravity that'll kill you anyways. You wanted
Thank
the simple
you.
answer.
Yes,
right?
I wanted the
Okay,
simple
yeah.
answer that doesn't make me scared of going backpacking
Good.
this weekend.
Perfect. Wonderful.
When we get close to snap picks, before we go to the high ground, obviously we're going to try out the lava because I've never tasted lava that isn't hummus. I took your recommendation, tried some hummus.
Cool it before you put it in your mouth.
Cool it before you put it
Like
in your
have a
mouth.
bucket of water handy. Take the
Okay.
rock hammer that's dripping gooey lava. Dunk it in the bucket of
Okay,
water.
so scoop up the lava with a hammer. Scoop
Yep.
up the lava. Would a stick work?
No, the stick will burn.
Okay, would like another rock, like maybe a long, skinny, like flat-sided, that sort of spoon-like rock?
Yeah, sure. You can hit one like
I just
that.
go find a rock to scoop, and then just carry it over to a nearby stream or lake or whatever, douse it, and then try to eat it.
Yes.
Okay. It is important to get the preparation right.
Yeah, you gotta have the right tools for the job.
Poorly cooked filet mignon won't taste right.
True.
Same with lava.
Yes.
Is lava safe for dogs to eat, and does it need a different preparation?
That's a good question. You know, I'd never considered it before.
Because you got to watch out for things like chocolate, grapes, garlic,
Yeah.
onions, things you wouldn't think about. Yeah,
Dogs are really vegan.
I know.
It's disgusting.
And lava smells like sulfur, so she would
Interesting point.
be interested in it.
Yeah. It depends how much you care about her intestines. Like, if you want them preserved and not cut open from the inside, I think I would probably steer her away from the lava towards softer choices.
Like real poop.
Yeah, poop will not puncture her intestines. I'm
Okay.
confident of that. Unless the poop came from a dog that it eat.
What if she does the thing where she sniffs the lava and licks it and then gags because she decides she doesn't like it? Should I encourage her to keep trying it because maybe she will warm up to it, like we did when we switched her kibble? Or should I just respect that choice because...
I don't think she'll warm up to it because it tends to cool off.
That does make sense.
Astra, to the stars, to the stars.